Good evening, everyone. Welcome to our today's webinar on electrical harness design with CATIA V5. I am Vaibhav Vyas, Senior Application Engineer for Altum Technologies in Software Solutions. I welcome you on this webinar on electrical harness design. First, before starting today's agenda, I will introduce my company, Altum Technologies. A few words about Altum Technologies. Established in 2010, Altum Technologies is a leading provider of complete digital solutions. We offer a comprehensive 3D innovation platform to our customers featuring industry leading solutions such as PLM software from Dassault Solutions, um, analysis solution from MSC Hexagon, 3D printing solution from Stratasys, scanning solutions from Arctech, and bioprinting solutions from CellLink. So Altum Technologies provides a complete PLM solutions covering all the aspects of product life cycle, starting from concept design, engineering, detailed design, analysis, tooling, manufacturing, and aftermarket. So covering all the aspects of concept design, we provide design software, 3D printer, scanner, and reverse engineering solutions. For engineering, we provide design software and 3D printer. And for detailed designing, we provide autonomous driving and 3D printing. For analysis, we provide additive manufacturing, autonomous driving, and multi-body dynamic solutions. For tooling, we have 3D printer, 3D scanners, and softwares. And for manufacturing, we have manufacturing simulation, robotics, and aftermarket, we have technical documentation software, 3D printers, and 3D scanners. Altum Technologies has been bestowed with some of prestigious awards, as mentioned over here. So without any further ado, let's start today's agenda. So our agenda will be, I will introduce the electrical harness design workbench, and we will get familiar with the terms which are commonly used in this workbench. Then we will understand end-to-end workflow of harness design, and I will demonstrate the capabilities of CATIA V5 software used in this process. So these are some of the applications, field of applications of electrical harness design. It is used extensively in automotive industry, in aerospace and defense, in marine and offshore sector, industrial equipment, high-tech industry, and many more. Advantages of creating harness in CATIA V5 are as follows. It reduces time and cost of electrical development lead time, to improve the quality and avoid issues late in process. It ensures collaboration for all stakeholders. It optimizes bundle accurately in full context. It synchronizes the electrical schematic to 3D design, or it routes 3D wires and cable to obtain exact bundle diameters and wire length. And it generates automated full-scale annotated drawings for form board creation and manufacturing documentation. So electrical modules for CATIA V5 will be as follows. We will start with setting up the environment for electrical design. It is a one-time settings which will facilitate our harness design in CATIA V5. So let's see how what are these one-time settings and how they are done. All these settings are needed to be done only once. After doing this, we are ready to start our electrical harness design. So first we will go to tools, options, and we will go to assembly design tab. And we will check and we will set the updates to automatic mode. And then we will go to infrastructure, part infrastructure, and we will keep the selections as shown. Keeping link with selected object is must. We have to check use root context in assembly, allow publications that should be active, or updates are needed to be set to automatic, and we have to synchronize all external references, and display dialog box option should be active. Next, we will move to equipment and system engineering tab. And from there, we will select electrical harness discipline, and we will select electric harness installation tab. So in harness management tab, bundle segment creation we will check. So geometric bundle is mandatory, that should be checked. Use customized display should be checked. Bundle segment color option should be active, and this is the most important segment naming rule. We have to set it to bundle segment, and all the other selections should be kept as they are shown. We'll come down a little bit, and we'll check segment connection and disconnection. Bundle segment support link, we will use publications. And we will come down a little bit further, and visualization for local Slack, we will check display Slack for all bundles. Then we will switch to electrical assembly design, and we will check snap to placed element is active. Then we will move on the top to general tab, and we will select parameters and measures, and we will check knowledge environment, and we will check this box of load extended language library. So it will allow us to load the external libraries into our CATIA V5. It will ask us to restart our session. We will click OK, and we will restart CATIA V5. So these are all the basic settings which are done one time. So now we are good to go for our part design and harness creation. So next module in CATIA V5 is in electrical design is electrical part design and catalog management. So we will design electrical parts first, and then we will store it in the form of catalog. So let us first discuss what are the steps for electrical part design. So we will open an already created 3D part, and we will export is we will save it and define it as one of the components mentioned in the table, which is shown further. We'll give connection points and save it. We will create a catalog structure. We'll save our electrical parts in the catalog. We will use that catalog to call the electrical parts in the assembly, and we will connect all the components. And then we will arrange all the parts, sub-assemblies, and electrical assemblies in the design workbench. So this is the set of electrical libraries and the terms and the equipments which we will come across. So we can define our equipments as any one of the equipment shown in this slide. So there is a mounting equipment, which is a non-electrical part and which will group electrical connection and placed into empty cavities. Then we will have equipment, which will be a complete electrical device. Then there will be a shell. The shell is a part which will be inserted into the equipment and which will receive the connectors. Then we will have connectors, which is a sub-element for the connection with other connectors. Then we will have contact. Then we will have filler plug. Filler plug is a component used to fill up unused cavity. Then we will have a back shell. So back shell is a component which are used to guide the wire extremities, and there will be a support or retainer. So it is used to support the bundle segments. Whenever there are long sections, we will use supports to give strength and to support our bundle segment. So in after defining these components, we will have to apply some properties, or we will have to again define it with some points to ensure the electrical compatibility. So for that, we will define cavity in the component. So cavity is a sub-element allowing one associated components amongst shell connectors, single insert connector, contact filler plug, and electrical connection can be defined between a cavity and a cavity connection point. So after defining a cavity, we can define termination. It is a sub-element. It is in dissociable form from the electrical component and corresponds to the contact crimped into a cavity. Then there is a connector connection point. It constrains a connector and a harness connector and ensure electric connections between them. Then there is a bundle connection point. Mm, Connection point connection point is defined on the harness connector. It represents attachment point for the bundle segment. So bundle connection point is the point where our harness installation will initiate. And then we will have a cavity connection point. So wherever there is a cavity, a mating part should have a cavity connection point. So it is a constraint between two electrical components, maybe a connector or a shell or a mounting equipment. And last is the back shell connection point. It constrains the connections between the shell, connector, or back shells. So in this chart, in the next chart, I will explain this that how the parts are compatible. So wherever there is a mounting equipment has to be defined with one of these connection points, whether it should be a cavity connection point or bundle connection point. So the possible mating component for mounting equipment can be a equipment, connector, stud, terminal block, or a bundle segment. And in order to define the mating parts, they should have one or more of the following properties. So as you can see, wherever there is a cavity, the mating part should have a cavity connection point. If a parent component have a cavity connection point, then the mating part should have a cavity. So if it is having a bundle connection point, then the mating part should have a bundle segment extremity. So like this, we can have equipment can be defined with these properties. And this is a set of compatible parts for equipment, and it can be defined with these. Likewise, shell can have a cavity connection point or bundle connection point. Mating parts for shell are as per the mentioned parts, and they can have a cavity connection point, cavity, or bundle segment extremity. Single insert connector can have cavity connection point, bundle connection point, connector connection point, etc. And their mating parts can have cavity connection point, connector connection point, etc. So a stud can be mated with bundle segment, shell, equipment, etc. External splice can be given bundle connection point and can be mated with a bundle segment, and bundle segment can have bundle segment extremity. Termination strip can have a cavity connection point. It can be connected to a equipment or a shell, and they can have a cavity. So like this, we can define terminal block, contact, filler plug, back shell, and bundle segment. So electrical, now we will discuss how we can design electrical parts and how can we manage our catalog. So we will get an electrical part, and let's have a demonstration of electrical part design in catalog management. So first of all, we will call already created a 3D model into our part design workbench, and we will define this part as the equipment. So we will select this part and we will select define equipment, and as soon as we'll click OK, you can see the top right corner. Now that part is converted into a electrical equipment, and we can see the logical pin and logical termination in the publication segment of the design tree in the right segment. So now we will define a cavity for this equipment. So we will define first cavity. We will select the inner face as the representation. Base face we will select as the representation. So after selecting a face, all the points we can be defined with respect to that face. So in the placement constraint, we have contact, coincidence, and orientation. So we will define point of contact for the cavity. We will select point on surface. Then we will select coincidence. So coincidence can be a line. We will right click, create a line, and we will define a line as the coincidence. So we will select the point and we will select the direction for the line, and we will give a random length of 20 mm. Then we will create a line for orientation. We'll select point and direction option, and we will select orientation as per x-axis, and we will click OK. So like this, we have defined our first cavity. So using same method, we will define our second cavity. We will create a point on surface option. Then we will create a line. So the dimensions and the line type can be used in any manner. So dimensions is only for physical representation. We can keep our dimension as much as we want, but there should be enough to physically to have a physical representation. We can here I have kept 20 mm. We can keep a little bit more or less. Only the properties will matter. So we have defined the third cavity using same method. So now we will save this part. It is completely defined. We have defined all the three cavities. Now I will open a new part. I will open a shell connector. So let me tell you, this shell connector is going to be fitted inside the cavity, one of the cavity defined in the equipment. So we will first define this shell connector as a shell. So we will select shell option, and we will select the shell connector part and click OK. So this part is now converted into electrical part, and publications and logical terminations are present over here. So now I will define a cavity connection point on this shell so that it can be fitted easily into the cavity. So I will select the back face, and I will select a point on surface. And for the coincidence, I will select a line. So a line should be the exact, the coincidence and orientation line should be an exact replica of which we have created in the cavity. And the orientation should point in the opposite direction as we have defined in the cavity. So I will select this point, and then I will reverse its direction. And now for orientation, I will select the same point, and I will select a line for that, and I will reverse this direction so that it is in opposite direction with the one defined in the cavity. So this shell also contains a cavity, and I will define a cavity connection point as well in the shell. I will select the point on circle option, And I'll quickly demonstrate how the point is created. And the procedure for creating line for orientation and coincidence are same. Let me again reiterate myself that all the properties which we are defining, like cavity and cavity connection point and bundle connection point, this will affect our electrical connections in when we will assemble them. So if there is any glitch in defining these properties, our assembly will not be done properly. uh, we have opened another shell connector. I will define it, and I will use same method. I have used same method to define the cavity and the cavity connection point. So we have defined two cavities and one cavity connection point so that it can easily fit inside the cavity. So I have already prepared some parts and I have defined the desired connection points for them. We will open a harness connector. We have defined a bundle connection point, connector connection point, and backshell connection point on the harness connector. This is our bundle connection point, connector connection point, and backshell connection point. So all these publications will be created when we define a property. So backshell connection point will have a bundle connection point. So bundle connection point, I will repeat myself again. It is the most important point, and we have to be very careful while defining that point because it will initiate our electrical harness. So this is the starting point of our electrical harness, bundle connection point. So we will save all the parts which we have created and which we have defined, and we will open a new window, a new document window called catalog document. We will go to new, we will select catalog document, and a new window will open. So a catalog document will have a chapter. We can rename, we can define the chapter as electrical parts or whatever electrical assembly which we are going to create. So here in this example, I am taking example of a simple circuit board. So we have created all the parts for simple circuit board and we have defined it. And now one by one, we are going to store all the parts into the catalog. So we will save the catalog, new catalog as electrical parts at a proper location. And in assembly, we are going to use that this catalog which we have created to call the parts and assemble them. So after saving, we can add a family of components. So from add family icon, we can click add family icon and we can add a family of components in electrical parts, and we can categorize our parts in terms of component families. So we will add a equipment family. So all the parts which are defined as an equipment, we can save it in the equipment family. It can be a simple equipment, it can be a mounting equipment, it can be a battery, it can be a radio, it can be a fuse box. So now I will add one more family of shell connector. All the shell connector we can place in shell connector family. Then we will add one more family of harness connector. So what I'm doing, I'm categorizing my catalog. I'm creating a catalog structure. So we can segregate all the components in terms of different types. So likewise, we will create a family for device connector, and last but not the least, we will create a catalog family for back shell. So after adding all the families, we will recheck that all the that it is categorized properly. So in order to add components, we will double click a catalog family to activate that, and from the add component icon, we can add components to it. So in equipment family, we can click on select document option. So it will prompt us to select the equipment. We'll select that part and we will bring it to the equipment family. So it will show that which part is saved in which family. So likewise, we will save our shell connector in the respective family. So as you can see, there are two types of shell connector. So we will select other one also. Let me make myself clear. We have to select one by one each and every component. We cannot make multiple selections in this. So if by mistake, if we have saved a wrong component in the family, we can simply delete it and we can activate other family, and we can save our component in the and we can save our component in the next family. Harness connector, we have selected in harness connector. Device connector will be saved in device connector, and back shell will be saved in back shell. So after adding components to the catalog, we will save this and we will switch to electrical assembly design workbench. And in this workbench, we will name this assembly as electrical assembly. And we will use this catalog to bring our parts in the assembly design workbench, and we will connect them. So we have moved to assembly design workbench. From the catalog browser icon, we will load the catalog which we have created. We will go to the path. We'll find our catalog and we will load our catalog browser. And we can browse through the equipment families that to check whether all the equipments are saved properly. Double click on the part and that part will be shifted to our workspace. Double click on shell connector. It will bring shell connector. Now I can close my catalog browser and I can move my parts and I can adjust my parts with the help of a compass. I will move the parts in 3D space so that each and every part can be visible, and as then they can be assembled properly. So after placing the parts, we will use connect electrical devices icon, and we will select our shell and we will select the cavity, and it will be connected automatically. So I will again open my catalog browser and I will use smart place icon and I will select second connector and I will place it in the surface using smart place option. I will use the compass to move it. And I'll use catalog browser to call other remaining parts. So I will need 4 instances of harness connector. Then I will need 4 instances of device connector. And I will need some instances of back shell. So after calling all these parts, I will use the compass to move them, and we will connect them one by one. So let me make myself clear and let me reiterate this. Our assembly will not work if the parts are not defined properly. Okay, so we have to properly define cavity connection point, bundle connection point, harness connection point. So I have, and now I'm quickly connecting and completing my assembly. I'll connect harness to device connector. A warning will prompt. We can ignore that warning. So I'm connecting all the harness connectors to the device connectors. And I will connect the remaining back shells to complete my circuit board assembly. And after completing, we will save this assembly. So we have successfully created our circuit board assembly and it is ready. So now I can start, now we are good to go to start our today's case study, which is car door harness. So we will load the car door template and we will load the catalog, which is already created for the car doors, and all the equipments, connectors, support clamps, and all the other necessary parts are already prepared and saved in that catalog. So we'll load our catalog for car door and we will browse through the connectors, single connector family. So in equipments, we have alternator, battery. We have single connectors. We have internal splices. We have support. In supports, we have clamped adaptive clamps. We have mounting equipment. We have wire. We have internal splices. So we will use this catalog to place the parts at their respective position so that we can we can install a harness through them. So next module is placing the electrical parts and connecting them. So how we are going to place our parts, how we will define their positions. Okay, so all this data is predefined in the form of a schematic. So this is a random schematic. So it is a line diagram which will show where there will be a connector, where there will be equipment, how the harness will float, what will be its connection point, where will be its termination, which harness will go into which connector, which harness will go from equipment to connector or from equipment to um, equipment through a set of connectors, and how, where the supports will be required, what will be the length of the two connection points. All this will be defined in the schematics, and with the help of the schematics we can preload, we can save our equipments and we can link them with their terminations and with their connectors directly. So we will explore that how we can call our parts in the assembly workbench, and what are the different methods apart from catalog browser and smart place which we can use to place our parts. So this is our simple workflow, that how our assembly should be there. So this is a line diagram and this is our physical representation, that how the schematics will work. So let us demonstrate that how electrical parts are placed. with the help of schematics. So we will load external data which we have already got, and we will use to place a battery equipment in the 3D workspace. So all the connectors and terminations associated with the battery will be automatically linked. Okay, so with battery, the terminations and both the connectors will be placed. So now we can use the compass to move and to adjust it and to place it at a proper location. So here the battery is placed at its correct location, and you can see over here the battery connectors are already placed as they are already linked in as per the schematics. Then we will activate a case fuse box, and I will go to external data icon, and I will load fuse box harness external data, and I will use manage link icon, and I will browse to the fuse box, and I will place the fuse box in the assembly. So all the connectors and terminations will be automatically linked. So if we use a smart place icon or catalog browser, we will have to link it separately. Okay, we will have to switch between the workbenches, and we will have to use manage link option to link it externally. Then we will load alternator harness, and we will load alternator part using manage link option, and we will place it properly in the at its position in the car template. As you can see, we are using extensively this compass to move our part to its proper position. Now we can use smart place icon to place um, connectors for alternator. So we will move to connector family, and we will select alternator connector from that. So we will select our first connector, and smart place icon will prompt to select a face, and now we will select second alternator connector, and we will use smart place icon to place it at its location. And now we will use connect electrical devices to connect both the parts, both the connectors to alternator. Okay, so after loading this connector, we will place the connectors for our door harness. So we will use smart place icon for this. Remember, I am not using manage link option, so I am going to place the connectors first. Then I will have to link those connectors with with their terminations separately. So I am placing my first connector, and I am adjusting its position using compass. The positions are predefined in the schematics. The terminations are predefined in the schematics. Now I will select my second connector, and I will place it using smart place icon. I'll select the top face, then I will move it using the compass. I'll rotate it to I will rotate it to its proper orientation. Then I will place my third connector. So first we are placing connectors, then we will place supports, and then we are going to link them. So I am placing my third connector. So likewise, I will place my remaining connectors, and now I will open adaptive clamps, and I will use this adaptive support as the to support my harness. So we will place it. We'll place it and adjust it as we have placed our clamps. So like this, we will place all the supports at its proper position. So after supporting, we will insert some battery connectors, and then we will link them. So we will load door harness. I will load door harness, and I will use manage link option to link our connectors. So I'll link my first connector. I'll click OK. Then my connector is linked. All the terminations, as you can see, are linked as yes. So I'll link my second connector. So in the extreme left column, all the connectors will be showing yes. So likewise, I will link my remaining connectors. So after connecting them, we have placed our connectors equipments and we have linked them as per the schematics. Now we are good to go for harness installation. So next we are going to install electrical harness. So first of all, we will insert a CAT product in the main assembly and define it as the geometrical bundle. We'll apply the settings, then we'll create a bundle segment. We'll define the starting point of harness. Then we will define the bundle segment. We will define the bundle route, and then we will manage the bundle segment and apply protection and supports. So these are some of the terminologies which we are going to commonly use in the harness installation. So what is a harness first? It is often referred as wire harness. It is a systematic and integrated arrangement of cables. The purpose of the assembly is to transmit signal or electrical power. So branchable is a harness which can be branched into different segments. So a bundle segment is a part of a branchable harness. Routing is the process of passing harness through or a series of harness through an environment to reach the desired area of connection. A splice is a connection of two or more conductors to provide good mechanical stability as well as electrical conductivity. And a termination is a sub-element ensuring electrical conduction between any type of electrical component. So this is our branchable segment, and this is our branch point. So from branch point, two bundle segments are branched. So let's demonstrate. Let me show you a demonstration how harness installation is done. So we have placed our parts at the proper positions. We will just verify them. All the parts are placed at their proper positions, and now we can start our harness installation. So before starting it, we have to switch to electrical harness assembly workbench. So we have switched ourselves to electrical harness assembly workbench, and then we have to add a sub assembly in the root assembly, and we will have to define that assembly as a geometrical bundle. So I have already defined door harness as the geometrical bundle. I will define harness 2 as the geometrical bundle. So we will have to activate harness 2 by double clicking it, and we will click on geometrical bundle icon. So harness 2 will be converted into a geometrical bundle. So in geometrical bundle, all our harnesses will be created and will be saved in that design tree. So in order to start harness, we will activate door harness, and we will open the multi-branchable document. So a branch definition dialog box will open, and we can define our bundle segment in terms of diameter, cross section, bend radius, and build mode. So in build mode, there are four options of slack, length, and bend. We can use bend radius also. And in order to route a harness, we will have to click on route definition, and we can define our harness route. We have selected our first connector, and we have selected our support. So as soon as I click on the support, a harness will float between the connector and the support. Okay, so I will route my harness through the series of support all the way to the desired connection area. So supports are generally given to take our harness through a proper path. So this is a branchable harness which we have created. So this can be branched into different branches. So we can click on apply, and we can click on OK. Now we will add a branch point to this harness. Add branch point icon we will use to add a branch point. So as soon as we will add a branch point to this harness, this branchable will be divided into a series of segments. So we are adding two branch points on this harness. So if we will redefine this, it will show three bundle segments of this harness. Now I will use this branch point to create a branch of harness. I'll use branch point 1 and the next connector, and I will click on OK, and I will use again route definition, and I will select again the same branch point, and I will install a harness all the way up to the third connector. Now I will use another branch point, the second branch point which we have created. And I will install a harness using this branch point. And I will click OK. So like this, we will add two more branch points to complete our harness installation. I'll add branch point to this location, and I will route a harness using first branch point. And I will route a harness using second branch point. So after completing our harness installation, we can manage our harness. We can change its diameter, we can change its properties, we can change its color. So we will have to click bundle segment definition. So as you can see, we have defined two branch points on this segment. So this branchable is divided into three segments. So I can select a segment and I can change its properties. I will select the second segment and I will increase its diameter to 15 mm, and I will click apply. So so our diameter will be increased. Then I can change the color of harness. I can set the color to blue. Then I can also change the cross section of the profile. And we will keep this profile, and we can apply rotation also. Lastly, we can apply the protection. So for that, we will select protective covering, and we can select our bundle segment on which we want to apply our protection. And we can double click on the start or end extremity to set an offset distance. It will also show the covered length and the tape length. So covered length is the overall length of the harness. So when we specify offset distance, the covering layer, protective layer, will not cover the offset distance. Okay. So like this, we can apply protective covering if our harness is passing through any passing nearby any sharp edges. Protective layer are required to be applied. Like this, we can instantiate different protective layers on the target harnesses. So after applying all the protective layers from both ends, our harness installation and harness management is complete, and now we can move to wire routing. So wire routing, we have to map our external data from the schematics, then we have to manage links, then create an electrical bundle, then we have to connect a geometrical bundle to that, and then we can route the wires automatically. So after we will verify that our harness is installed properly. Then we will map our devices, we will map our equipments, and then we will have to verify whether our external data is loaded. So in this electric process interfacing tab, we will have to give the path of our external data. So here we will copy the path and we will paste it in the external data repository, and we will place our catalog path in the desired section. Then we will go to assembly design workbench, and we will link the connectors, and we will place the internal splices. We will link the connector which was missing, which we have left to link. Then we will place internal splices. We will select internal splice. We will click on place icon. And we will place it in the harness. So like this, we will place all the internal splices in the harness. And after that, we will switch to wire routing workbench. And then we will and then we will connect a geometrical bundle to the electrical bundle. So we'll activate electrical bundle, and we will add door harness geometrical bundle to the electric bundle. And then we will click automatic wire routing. So after clicking automatic wire routing, these are the set of wires which are preloaded as per the schematic external data. We will bring it to wires to route, and we will click on route. And you can see our wires will be successfully routed, and automatic wire routing report will be generated showing all the wires are successfully routed. So it's a simple and easy process, but it depends entirely on the external data. So after this, our last thing is remaining is harness flattening. So harness flattening have a set of procedures. We have to define flattening parameters. We have to import form board. We have to extract harness, then flatten the harness, then manipulate harness. So why harness is important? So after wire routing and harness installation, um, flattening is done for manufacturing purposes. So we can design panels, and we can uh, know the overall harness length, etc. So let me give you a demonstration how harness flattening is done. So we will define a harness flattening. We will open a harness flattening assembly in the assembly design workbench. And then we will import a form board. We'll load our form board, which is already created. Then we will switch to electric harness flattening, and we will set our harness parameters. You can see on the right side all the icons are inactive. So as soon as we click OK after defining the parameters, all the other icons will be activated. So now I will use this form board face to extract the desired harness. So I will open the harness in the other contextual window, and I will select the geometrical bundle which is to be extracted. Then I will flatten this harness using flattening icon. So select harness and select the face and click OK. So this will be flattened. So after flattening, we have to manipulate the harness, and we have to set it as per the line diagram. So we can rotate harness as we can see. I will give -22, and I will set the face as the active plane. Then I will arrange the junction at equal angles. Then I will arrange the junction like umbrella. Then I will roll the harness using the roll tool. So what I'm doing, I'm manipulating the harness, and I'm bringing it to the status as per the schematics. So purpose of doing harness flattening is it will clearly demonstrate all the position of the connector, and what is the length of each harness, and where the branch points are located, and where the bundle segments are located. So I am using quick roll option. So after doing this, we can add length tolerance. By using length tolerance, I can increase or decrease the length of the harness. So it is meant only for manufacturing purposes. It will not affect the overall length in the harness installation. So I can increase or decrease my length. Last is scaling our harness. I can scale my harness up and down. So I will give the design, so design length and flat length. So design length I can reduce by using flat length. And if I click on the restore length icon, my length will be restored. So after harness flattening is done, drawings are created. So drawings I am not going to cover. So this is a random drawing which will be created after harness flattening. So we have come to end of this session, and I am open for questions if there are any. Okay, thank you for joining our session.
Hello, Vaibhav.
Yes.
Thank you so much for your amazing session. So we do have certain questions.
Yes. Yes.
Okay. Ijaz Malik has asked routing of harness from dashboard to door.
Okay. Routing harness from dashboard to door. So
Yes.
only shown the how routing is done in the door harness, but yeah, we have to um, keep our schematics ready, and we can route our harness from dashboard to door. So in this session I have only demonstrated how the harness is routed in the door only.
Okay. So maybe we can connect with Ijaz separately and you can explain him.
Yes, yes.
Okay. So the next question we have from Niranjan.
Okay.
His
Why
question is
harness flattening is required? He is asking. Okay.
yes.
Yeah, I have already covered this in the session. Harness flattening is required for manufacturing purposes. That mm, we need to design the panel. We have to know the overall length of the harness, and what are the positions of the connectors and how much space will be required in the panel. So right, for this we will need harness flattening to in order to know the each and every position of the connector branches, etc. Yeah. uh,
Okay.
any other question?
Yes.
Yeah.
The next.
uh, yes.
Yes. What is schematic?
Yeah, schematic is a line diagram. The schematic is a external line diagram which is prepared by an electrical engineer. So it contains the information that what type of connectors are needed, what type of wires are needed, what will be the material of the harness, and what will be the flow of our harness. So it will decide the flow of harnesses from connector to connectors, connector to equipments, and equipments to terminations, and connectors to terminations. So depending upon our schematic, we will install our harnesses, and depending upon the schematic, we will install our wires through harnesses. So it is our input for harness installation in simple terms, I can say.
Okay. Thank you, Vaib. The next question is, could you please explain the importance of catalog management?
Yeah, so catalog management helps makes our tasks of placing the equipments very easy. So we can categorize our equipments in terms of different categories, and we can easily call the parts in the assembly workbench, and we can easily manage our electrical assembly with catalog management.
Okay.
It makes our solution more time friendly. Actually, it will reduce our time for electrical assembly.
Okay, understood. These are some of the questions that we had got, Viber. So any other questions or queries, you can still put it in the chat box.
Uh, yeah, thank you. I would like to thank our audience to joining our session and for the interesting questions. You can keep following our channel, and you can write us on inquiry.altum.com. Sheetal, you can mention that ID in the chat box.
Yes, I'm doing that.
You can reach us through inquiry@altum.com, and you can ask your queries anytime to us. And you can also suggest that what are the upcoming topics which you would like to see in our upcoming webinars.
Okay, done. Thank you so much, Vaibhav. Thank you so much, everyone, for joining our session today. I have written in the chat box. You can please note down, please send us your queries and other details on inquiry@altum.com. Also,
Thank you. Yeah.
please uh, please follow us on our LinkedIn page, that is linkedin.com/altum technologies. Done. Thank you, Vaibhav. Thank you so much.
Thank you.